we will start in just a minute, but in the meantime, just in case you, the lay of the land, the bathrooms are out that door, go up that outside hall and out that doorway to the left and down that hall. And we're thrilled about tonight and about this evening's speaker. But we'll start first. We're Margie Bushman and Wes Rowe of Santa Barbara Permaculture Network. And this Marine Permaculture event we're your host for this event. And it's a part of our Civics 101 for Climate Change ongoing series. It's been going since 2015, I think, right? And we've been doing, that was after the Paris talks and the COP21. And we thought it was very important to come back to our community and alert people to what was happening. And so we brought numerous speakers around climate. We noticed it wasn't still being spoken about a lot. So once again, we've been doing programs for almost 20 years, and we decided to focus on climate and bring as much information, as many speakers as we could, and including tonight's speaker, which we're just thrilled to have with us. First, we will thank our sponsors. Santa Barbara City College Environmental Hort Department is one of the main sponsors. That's why we're in the Fay Blonde auditorium this evening. And there's a lot of permaculture happening up here. If you go outside and to the left, there is a permaculture garden. And in the Environmental Hort Department, you can take a permaculture design course. And there is one coming up this summer, and we'd like to ask Daniel Para Hensel to stand up briefly. He teaches that PDC and he's an adjunct professor in the program. And it's an amazing way to get your permaculture design course. It's 5 credits and it's a requirement for the landscape design 2-year program and for the 1-year restoration certificate. So it's quite amazing the impact it has, and you see a real difference in the way the students come out after taking the permaculture design course. Our other sponsors are Amasi Beauty and Pharmacy, and they're the local seaweed kelp that you're going to be hearing about tonight. They are actually in Santa Barbara. Pharmacy is Daniel Marquez, and he has a 25-acre lease off the Goleta Pier where they're sustainably growing kelp. And then Antoinette, his partner, with her beauty product, Mama Sea Beauty, takes that sustainably harvested kelp and makes this wonderful skin products, really wonderful. I've left some brochures over there in her book. It's really wonderful. So that's our local connection to this work. And as you'll hear tonight, it's really, really important that we learn about our coastal ocean system. Even in some of our earlier work, we were very involved in a lot of the work Santa Barbara Food Alliance around our food systems, and we really wanted people to remember that our biggest food system, or one of the larger ones, is our ocean. And we're living right on the coast, but we forget that. So our other co-sponsors are the Santa Barbara Independent, who always supports our work, Santa Barbara Food Alliance, Ticino, who many of you passed on the way in, which is an herbal coffee product, and is a local company making these wonderful herbal coffees to get you off of your coffee habit. It's better for your health, and it's wonderful. You can find it in all your stores. Caroline, are you in the audience? Do you want to stand up and take a bow? Yeah. Caroline McDougall, Ticino.
Quick coffee. You can drink Ticino in the afternoon.
Right. Antioch University has been partnering with us quite a bit, and they will be the location for the workshop tomorrow. And if you're interested in the workshop, make sure, we're asking you to sign up on Eventbrite, but there's also a sign-up sheet on the admissions table as you come in. Let us know that you're coming. There is limited space for that. And that's sort of a deeper dive into what Brian will be talking about tonight. And Blue Sky Biochar. And Michael Whitman is not with us tonight, but he also is, he's down in Thousand Oaks. He's done a lot of work around biochar, including the city of Thousand Oaks. It's their official policy now to use biochar when they're planting new trees, and that was first proposed as something to do with the drought, because biochar makes the soil, among many other things, hold more water. And step in at any time if I'm forgetting somebody. El Capitan Canyon Resort. They are on the coast of Gaviota Coast and have a they call it glam camping, glamorous camping. It's a beautiful location, and Roger Himovitz has supported programs of ours in the past as well. Okay, so good. Okay, so tonight, this topic of marine permaculture and the oceans is so important, and what Brian will be sharing with us about how we can turn some of this around. So we're all worried about climate, we're finally learning about carbon, atmospheric carbon, and how to sequester it. I think our community finally has gotten the part about soil, carbon farming. But the ocean part is a little less familiar to us, and Brian will, I know a lot of the statistics, like 90% this, 99% that, 93% that. So
every second breath.
So
if you don't like the ocean, don't breathe the second breath.
So we'll let him explain that. But the oceans are responsible for sequestering that atmospheric carbon, and because of the vastness of the oceans, that they are taking in an inordinate amount of it, and the waters are heating up, as we read about all the time, and ocean acidification is happening. One of our favorite people is eco-philosopher Joanna Macy. And many times we begin when we do a part of our talk at the PDC, we ask this question of students, and what she asks of her audiences, which is, if you met an ancestor of yours 300 years in the future, what do you think they would have to say to you? And then, surprisingly, she turns that around and says, no, they would say, thank you. How did you know what to do? And tonight's speaker, and some of the speakers in March we had John D. Liu from the ecosystem restoration work, talking about restoring very large pieces of land back to health so they can sequester. But now with the oceans, a similar strategy for how we can, instead of focusing on the problems which we drilled down on very deeply, but now we really do actually know what to do. And Wes and I are involved in permaculture for the longest time, 20 years, and we feel that this speaker represents what we're interested in, which is feeling good about what we can step forward and do. And I think with that, we'll go ahead and, yes. So, Dr. Brian von Herzen, right? Not Herzen, but Herzen, is the co-founder with his partner, Rebecca Truman. And Rebecca, raise your hand. We want to know the co-founder of the Climate Foundation in Woods Hole, Massachusetts. But their work takes place around the world, and Brian is multidisciplinary, and he's a scientist, he's an engineer, he's an entrepreneur. His work takes him everywhere, and he's soil and water. Some of the work that I was most impressed with is we were in India for the International Permaculture Convergence a year and a half ago, and one of the things we noticed, sanitation is a huge problem. And Brian, one of his earlier projects was about that, how to and I encourage you all to go on Climate Foundation's website, was about biochar and how to they don't need a sewage system, they need something that takes that, turns it into something that can be used for the soil. So that is, Brian is has degrees in physics, engineering, and planetary science from Princeton and Caltech, and is a Hertz Fellow. And I think with that, we'll welcome him to the stage.
Well, thank you, Margie, and thank you, Wes, for this wonderful introduction. And thank you all for being here and being interested in this new field of marine permaculture. How many of you saw The Biggest Little Farm last night? Show of hands. Wasn't that incredible? One of the things I loved the most about the question and answer period afterwards with the farmer was his notion of what it took to actually turn around the farm over 7 years. And what I loved about his response is that he said, you know, it's the consciousness of humans that ultimately turns around nature, that turns around the process to where we can rebuild ecosystems and rebuild an equilibrium, if you will, or he even referred to a disequilibrium, but one where it's the consciousness of humans that can turn around dire situations. I'll also quote one of my favorite quotes from Winston Churchill, that is that you can count on the Americans to do the right thing after they've tried everything else. I have a great faith in that, and that's what keeps me going oftentimes, is knowing that we will eventually do the right thing. And so that's been part of the inspiration for me. One thing that the film brought out last night on land is that by regenerating the soil, and I will add regenerating the seas, we can build climate resilience into each system that we do, into each project that we do, to the point where his farm was able to resist far more severe droughts because it had the resilience. It had the ability to absorb 5 times as much moisture as the neighboring farms. And what that meant was, when we had the devastating floods of the last couple years, instead of running off all that soil into the sea, we actually kept the water in and had it go into groundwater. We kept the soil, and that cover crop was able to sustainably capture 5 times as much moisture. So that's a fantastic example. The second one that Margie brought up is biochar. And that's something that every time we're planting trees with biochar, as we've done projects in India and around the world, we're doubling the drought resistance of those tree plantings. So there's another example, a project. And as I'll show you here, when we regenerate kelp forests offshore with marine permacultures, not only are we regenerating those ecosystem services, but we can also be building in climate resilience against the next El Nino, against the next marine heat wave. And that means that when those heat waves come, we will have those ecosystem services resiliently there to last day in and day out. And that's a key aspect of regeneration. Not only getting them back, but actually making them resilient and building in that resilience for decades to come. And so we're taking many examples from the permaculture world. And I've been working on permaculture and regeneration for quite a while now. We've been going down to Australia and learning a lot and refining this notion of regeneration. And I think this idea of taking financial capital, turning it into environmental capital and other forms of capital, having them pay dividends in terms of actual regenerated soil, regenerated kelp forests, and regenerated ecosystem services that can then regenerate economies and jobs. That's the kind of virtuous circle that we see possible. And that's where we like to take this, first in soils and second in the seas. We like to quote Paul Revere. Becky and I are both near Boston. Once if by land, twice if by sea. We're going to need to use both hands to really address our climate challenges. And that's one reason we do work in soils and seas. And regeneration is so much about rebuilding and regenerating life in the soils and life in the sea. And they're both huge, which is one reason that we've started from the soil permaculture movement and moved to the marine permaculture and looked at literally 100 million square kilometers between here and Australia, as I'll show you a picture of later. So first I'm going to talk about the problem and what we focus on with Climate Foundation. We've found it really effective to talk in terms of global food security, because it turns out, well, about a third of the planet, at least 3 billion people, rely on the ocean for their primary source of protein. And this during an era where we fished out half of all the fish biomass in the ocean in the last 30 years. And 90% of all the big fish are gone. So we've taken out most of the barn animals. If we just close the barn doors, we're not going to actually be doing much. We actually have to regenerate some life in the ocean for this to work well. Similarly, and that's where the ecosystem comes in, we've got to get the ecosystems working, and we view the kelp forest as a model for that process. Partly because it's been very hard hit in the recent decades based on the warmer temperature of the ocean. But secondly, because it is a model ecosystem that works. And so when we're lost or trying to figure our way, figure out how should it actually work, if we turn to a kelp forest and see how the kelp forest is working, we can learn volumes. That can be our safe harbor, if you will, for thinking about how do these ecosystems work on their own. They've been working for millions of years. I was amazed by a statistic, and that is, you know, the sea otters used to be up and down this coast, just all over the place. And about 300 years ago, the Russians came in first, and other people came in and took out all these sea otters, right? And the amazing thing is, I realized these kelp forests have been around for at least 5 million years on this coast before the climate had changed much. And the sea otter collapse was in the blink of an eye, like less than 1%. I mean, from 5 million years to 300 years, it's many orders of magnitude. And so when I think about how long that kelp forest was existing in harmony with the sea otters and other pinnipeds, sea lions, and even whales, you've got that equilibrium working. And when you have a really healthy ecosystem running, you've got this huge diversity of species. And that diversity of species builds in resilience. And so regenerating that, we see as a really key challenge and an opportunity. And when I think about how we've collapsed various ecosystems, whether it's the sardine fishery off Monterey, or the sea otters, or these other elements, it's a question of what scaffolding do we need to build in order to regenerate those ecosystem services that existed that we have no living memory of today. And I'll show you a couple of examples of that as well. And finally, while we're at it, if we can regenerate the kelp forests, and if we can regenerate the soil, maybe we can measure the carbon that we're exporting out of the atmosphere into the soil and into the seas. And as we measure that carbon, we can actually count that carbon as a climate positive event. And so we see doing all three of those is really essential to where we can take this. So first I'm going to talk about the problem. And like it or not, 93% of global warming goes into the surface layers of the ocean today. And we're talking about an average of 1.1 degrees Celsius warmer ocean waters for the top several hundred meters. In my hometown of Massachusetts, Woods Hole, Massachusetts, I've looked at 130 years of the temperature records of the water because they started measuring this in 1888 when the Marine Biological Laboratory was established. And they've had a continuous temperature record ever since. And if I integrated up all the temperature measurements from 1888 to 1950, and then I compared it to the average temperature between 2000 and 2010, that one decade. And I was amazed to see an increased temperature of 2 degrees Celsius, which turns out to be about 3 degrees Fahrenheit. So Woods Hole was getting twice the global warming of most of the ocean. And believe it or not, our project in Tasmania has seen 3 to 4 degrees Celsius higher temperatures, and the result is 95% of their kelp forest is gone. So they've actually built the political will to turn this around, to restore the kelp forest there. And that's a project that I'll tell you about that we're currently working with the University of Tasmania. So that's how severe this problem is. The other key aspect, this slide is from Charlie Barron, who's one of the foremost coral biologists in Australia. And it talks about how these coral reefs, these little spots that are shown in brown here, are the canaries in the coal mine, because they live within 1 degree of mortality all the time. And so they're one of the first ecosystems to go. And what really surprised me is that at the beginning of each extinction, it's the coral reefs that go first. And then it affects the pelagic fish, because 1/4 of all species in the ocean spend some part of their life cycle on the coral reef. And the seabirds, because the seabirds get the fish off the coral, off a coral reef, and then they fly hundreds of kilometers and poop and pee and do everything, and transport nutrients. And so the seabirds have an effect on land and sea. And it turns out this a collapse of one ecosystem oftentimes precedes the collapse of other ecosystems. I'm going to tell you one story from northern Japan that really shocked me, and that is in 1897, the Japanese island of Hokkaido, they harvested 1 million tons of sardines every year, year after year after year. It was an amazing, actually it was herring, the herring fishery off northwestern Hokkaido. They did that just about every year until in 1953, the herring population went extinct from overfishing. A few decades later, the Kelp Forest made of saccharina was decimated. And it was decimated, they went back and they measured the isotopes in those kelps from recent years, and they had in the museum a piece of saccharina kelp from the early 1900s. And they measured the isotope there, and they found out that the kelp forest itself was being fertilized by the herring. That the herring were actually feeding the kelp. At the same time, the kelp was the nursery, the egg-laying location for the herring. So here's this beautiful herring ecosystem and a beautiful saccharina kelp forest, and they depended on each other, and now both are collapsed. And so this is the kind of effort where when we get marine permaculture right, we can take a floating island of saccharina kelp back near the shores of Hokkaido, add a few herrings similar to the herring that were, and get an agreement with Russia to not overfish in the Sea of Okhotsk. And then we could actually consider rebuilding that herring fishery. And if we can do it in Japan, why couldn't we do it off Monterey? Why couldn't we bring back the sardine fisheries that were? And that's the kind of regeneration we're talking about. Bringing back the forage fish populations that feed the entire ocean. This is what we mean by regenerating life in the ocean, and this is what we mean about marine permaculture. And it's really the fate of 3 billion people on this planet depend on getting this answer right. They depend on actually regenerating the fish in the sea. And so we think about enough fish for people and enough fish for nature. And so that's really a key aspect of this. These 5 mass extinctions were associated with spikes in CO2. We know that they're covariables. The high temperature and the high CO2 go hand in hand. And you don't even have to ask what caused what, because the reality is they're covariables. If you change one, you change the other, just like an ecosystem. The climate is a complex system, and so are these kelp forests. The largest one was this Permian Extinction, and what is very sobering to me is the similarities between the massive Permian Extinction and what we're seeing today. The similarities, what I was surprised, that this extinction occurred not by fire per se, but by asphyxiation. And the surprising findings in recent years are that the Permian extinction was devastating, first of all, but it was about low oxygen in the ocean. That the oxygen levels in the ocean, and Wes was right, more than half of the oxygen we breathe comes from the kelp forests and the plankton forests of the ocean. And to keep that oxygen system going, we've got to keep life in the ocean going. And what happened 250 million years ago was anoxia in vast portions of the ocean, which led to hydrogen sulfide and other gases coming out, which are major ozone depleters, and those ozone depleters resulted in a lot of ultraviolet, a lot of cascading problems, with the net result that most of the trees on the planet were gone. And 70% of the land vertebrates were gone, and 96% of the marine species disappeared. So what concerns me today is that we're already on this track. The trees died en masse. It was a major problem. And the reason, that I'm concerned is that they've already measured a 2% decrease in global oxygen throughout the ocean. So it's like we've got these oxygen meters, and the oxygen meters are starting to tilt down, and they're starting to accelerate. So macroalgae, kelp forests, and microalgae are essential for oxygen in the ocean, for life to be regenerated. And that is one reason we consider this technology to be so important. It is our life support system. If we don't support the circulation of the ocean, and that includes this vertical upwelling that brings nutrients and also ensures there's enough oxygen down deep, this is the lifeblood of the ocean and life in the ocean itself. And that's why we consider these approaches so important. So the question we ask is, can we come up with a way that is environmentally and economically sustainable so that we can scale this to a point where we can do well for nature and also develop enough capital to scale this to a significant point. And that's what we'd like to see in land farming with multi-trophic permaculture style land farming. And in the sea, perhaps we can accelerate even faster and enable these fisheries to thrive. I was shocked and amazed that the UN special report this month said that 1 million species out of an estimated 8 million species are threatened with extinction. Now that to me is extremely sobering. I think we've got a good chance of actually staving off the Anthropocene if we get permaculture right on land, in soils, and in seas. And that's what gets us up in the morning, is to figure out how to do that. So some examples, first of all from Tasmania, these are the heat maps that we saw from 2010 to 2017 of the warm East Australia current coming down and increasing the temperatures off of eastern Tasmania by 3 to 4 degrees Celsius. And the consequences of this were devastating. This is a picture of the Macrocystis giant kelp. That's the kelp we have right here off of Santa Barbara. And what's happened, they used to commercially harvest this kelp in the 1960s and 1970s, just like off San Diego. And it wasn't the commercial harvest that caused the problem. It was this warm water with low nutrient levels. If you don't have nutrients, you're not going to grow anything. You have a desert. And so this transition to high temperature and low nutrient levels has resulted in a decimation of the kelp forest. And we're now at the point where we're teaming with the University of Tasmania to see how can we turn this around. Similarly, the Catania kelp forest off Western Australia, they've lost 1,000 square kilometers already. And it all shifted during this big warm event that occurred in 2011, 2012. And this is what are some of the differences that it looks like. You go from a canopy forest with a lot of habitat for forage fish to something that doesn't have canopy and far less habitat and biomass. And these are the kind of transitions that unfortunately are bistable. It's like Easter Island. You can have that tropical rainforest or you can have just no trees at all. And very similarly, we see in Northern California, you can have a kelp forest or you can have an urchin barren. And once you have the urchin barren, you can't get back to the kelp forest until you've addressed 99% of the urchins. So that's a serious problem that we've seen off of Australia as well as off of Northern California. And those forests are home to some iconic species, thousands of species. This is a picture of the leafy sea dragon, which is the state symbol of South Australia. Imagine losing your state symbol because you didn't have any more kelp forest. That's what's on the table. The weedy sea dragon off Tasmania faces a similar plight. And this is a charismatic megafauna. These are the Nemos and the Dories of the kelp forest. In fact, Dory found her parents in the kelp forest. And I think she did our marketing for us. She said, blue water, kelp. Kelp's better. So we're hoping that we can build on that and really try to turn that around. I'm going to bring the story directly to Santa Barbara because we did some research and it turned out the U.S. Geodetic Survey in 1848 went up and down the coast and did a geodetic survey of the coastlines of the United States. Today, we have no living memory of the kelp that once was. But back then, we go back to the maps, this one from 1853, and we find on the maps is drawn a river of kelp from Point Concepcion to Mexico that's almost 1 kilometer wide. Imagine that. And growing in 20 to 25 meters deep of water. So what happened? What happened to our pre-industrial kelp forests right here in Santa Barbara? Well, in 1868, there show the river of kelp. It's this beautiful, healthy river right off the harbor. It just goes, it's amazing, growing in 20, 25, and even deeper meters of water. I mean, it's just amazing to see this river. 1888, a healthy river of kelp. But by 1939, the roads had been put in place. The farms were farming. The runoff that was shown so aptly in that movie yesterday was happening. And the net result is you get siltation and turbidity in the water. And if you're a juvenile kelp sitting 20 meters below the surface and you're trying to get enough sunlight to grow to the surface, and all you have are deep overcast days of silt and turbidity, how do you get enough light to grow? And that's the problem that we're seeing. If it's that change where we've got the runoff and the turbidity, so you've got half of a kelp forest here, but you can see it diminishing. And then as we fast forward to satellite photos, we see just a few remnants here today. And we call this shifting baselines. The shifting baselines are, we have no living memory of the kelp forest that once was. And yet, we know from the history books how rich it once was. And that's a key opportunity for us to restore those ecosystem services in our city, in our region, and in our nation, and around the world. And we see that as a key opportunity. In Northern California, more recently, it hit the New York Times that we lost 93% of the kelp forest off of Northern California, north of San Francisco, and now purple urchins are grazing the seafloor. It's been a devastating bistable shift, and it's one that we have to try to address more fundamentally. This was caused by the warm blob, partly, and the strong El Nino, and the net result was high temperatures and low nutrients, just like we see in Tasmania, and this decimation of the kelp forest itself. Amazingly, it wasn't just the kelp, because the forage fish depend on those nutrients as well, and over those same years, we saw a reduction of an order of magnitude in the sardine population. And that resulted in thousands of starving pinnipeds and devastation of the seabirds as well. In fact, I think about 3,000 starving sea lions were rescued up around Sausalito, and that was just a drop in the bucket. So, you know, some of these kelp forests will recover. It'll take longer for the sardines to recover, and even longer for the seabirds and the sea lions to recover, because they rely upon many years of growth for their life cycle. And so that's the real challenge, is to rebuild those natural ecosystem services and to do it consistently. These are the challenges we're facing with climate disruption. And what we have to ask is, how do we build a resilient system? How do we build a system that even in the El Nino years, we can support those ecosystem services that are needed to keep nature alive and prevent collapsing ecosystems? And that's what we asked and looked for with marine permaculture systems. Greta Thunberg does a great job of saying, look, this is intergenerational inequity. We need to do our best to leave as many species on the planet that we were born with. And so when people say the Anthropocene, I say not on our watch, that we have to do everything within our power to keep these species alive. And I think that's what it comes to. Our friends and our colleagues have been striking on Fridays to really bring out the intergenerational critical importance to keep our planet going. And I think it's regenerating life in seas and soils that's going to do it. And that's what drives us to continue to work on these approaches. So I think we've described the problem well enough. Let's phrase the solution as starting right here at home. What if we had a way to regenerate the kelp forest that once was? To regenerate the kelp forest right off the coast of Santa Barbara, the river of kelp, nearly 1 kilometer wide, from here to Mexico. What if we could regenerate all those ecosystem services and regenerate our ability to feed nature as well as the planet, the people on the planet? That's the big question that we ask. And it's this vision of the kelp forest. And what I love about the kelp forest, it's our own tropical rainforest sitting right here. We've looked at the numbers, and everyone thinks of the tropical rainforest as the incredibly productive ecosystem that it is, with verdant trees and thousands of species and all the rest. But what if I said that right offshore, right here, we had a kelp forest system that was every bit as rich, in fact, in some ways even richer than the tropical rainforests of Brazil? That's what we see with this beautiful image of the kelp forest, and we have the numbers to back it up. So at the top here, we've got a picture of the open ocean covering 65% of the Earth's surface. Pretty low productivity. It's kind of an ocean desert. Not many grams of carbon per square meter per year in terms of fixation of carbon. But it still is a lot of the Earth's net primary production because of its enormous area. And then the second purple row here is the tropical rainforest, which covers 3.3% of the Earth's surface and fixes a whopping 2,200 grams of carbon per square meter per year. So it's extremely productive. And it's responsible for about 20% of the carbon fixation in our natural ecosystems on the planet. But what if I told you that our lowly algae beds and reefs, of which kelp forests and others are included, had not only the productivity of the tropical rainforest, but a whopping 2,500 grams of carbon per square meter per year. It's actually fixing more carbon flux than the tropical rainforest. That to me is amazing because it's sitting right off our backyard and we hardly notice it. And yet it's incredibly productive. Now this number here is pretty small, but imagine multiplying this biggest bar by this biggest bar and looking at the 100 million square kilometers between here and Australia and saying, if we could take this sliver of life living a few hundred meters off the shore and understand how to cultivate that on the open ocean, we could have an amazing solution that could feed the planet, regenerate ecosystems, and even balance our carbon budget. That's, to me, an amazing proposition, that this productivity could apply to this kind of area. And that's the inspiration, fundamentally, behind a marine permaculture approach, using nature as a guide. Now, before global warming, we had natural upwelling coming up to the surface, and if you had an offshore wind, like a Santa Ana, you'd actually blow surface water away from the shore, and cool, deep water would come up and nourish the kelp forest. That's what happens naturally. When you have global warming, there's an upwelling failure because the warm layer of water has gotten deeper and the water's gotten warmer. That increases the barrier to this upwelling. So the upwelling doesn't get all the way up to the kelp forest. It's actually blocked. And the net result is the nutrients don't get there and the cooling doesn't reach the kelp forest. So with marine permaculture, we take a large hose and get it down below the thermocline, below the nutricline, and using wave energy and solar power, and even wind, bring that water up from the deep and irrigate a square kilometer of kelp. And we have seaweed farms today off of the Philippines and Indonesia that are being irrigated by a marine permaculture system. And we're seeing a dramatic restoration of their historical productivity that occurred in decades past when we didn't have the warm layer of water. And so we see that as an incredible model that we want to test in Tasmania as well, where we're doing our project right now, and ultimately in Northern California, where we've lost 95% of the kelp. And in future years, when we're looking at heat waves hitting Santa Barbara and hitting Southern California, to be able to bring this technology and ensure resilient ecosystem services for decades to come. That's the inspiration behind it. And so here's a vision of a large square kilometer system that's using wave energy to drive literally a flapper valve going up and down, nothing more complex than what's in your toilet. And literally with every wave, that flapper valve opens and closes and pumps gallons and gallons, in fact cubic yards of water, up to the platform layer. And a kelp in blue water, a kelp can grow just fine in 25 meters of water. So you get out of the surface, you get away from the navigational hazards, you get away from the hurricanes and the storms. If you want to run away from a hurricane, go down. You go down because the deeper you go, the smoother it gets, the less forces there are. And so we use that substrate at a depth of 25 meters to grow this habitat that's replete for sardines, forage fish of all kinds, and it becomes an incredible home for these forage fish. We get this habitat, these kelps will grow half a meter a day, which means in 90 days you can have a 45-meter harvest. And you can partially harvest the way they did in San Diego in the early 1900s, just the top 1 or 2 meters, because it grows out along the surface. And then in another 3 months, it'll grow again. So it's a partial harvest that can produce dividends year in and year out. We've estimated that for a square kilometer system like this, we could potentially produce $1 million a year in kelp sustainably harvested and $1 million potentially in fisheries. Now the fisheries remain to be proven and determined, but even if one of those comes true, we should have an economically sustainable approach to sustainably harvesting offshore and providing these ecosystem services as well as a sustainable economic model. And so it's that vision that ultimately enables marine permaculture to exist without tanks, without nets, without fish feed, and without deep water moorings. Now that's permaculture, right? Because all we're doing is filling nature's nutrient value chain gaps that have been caused by climate disruption. In particular, this nutrient gap that occurs because of the warm water. It's a bit of a runaway feedback loop. The warmer it gets, the more stratified it gets. That's what happened in the Permian, and that's what we have to be determined through our conscious understanding to prevent happening again and enable a sustainable civilization and sustainable life on the planet. So what's our technology roadmap? More than 10 years ago, we started in Hawaii with phase 1, demonstrated upwelling with these pipes, and demonstrated that we could grow algae. This was with the University of Hawaii. In phase 2, we won the BlueCanMe challenge from the Department of Foreign Affairs and Trade in Australia, and they funded us to test out a scaled version of this that would show that we could have improved growth with economically valuable red seaweeds in the tropics in Indonesia. And now in phase 3, with the support of the Grantham Foundation and other private foundations and individuals, we've been able to go to the Philippines and show that we can lay the foundations for hectare scale permaculture. Each subsistence farmer in the Philippines is allowed to grow 1 hectare of seaweed. And that's worked out great. There were communities, rural communities, thriving throughout the 1980s and the 1990s. And their communities were doing wonderfully well. And then the heat waves started hitting, the marine heat waves. And these people live on the front lines of climate disruption because they have no crop insurance, they have no backup. And when those crops start failing, their communities collapse. And we witnessed the collapsing communities this year alone. They called in the central Visayas in Cebu a condition of calamity, a state of calamity, when they lost 85 million pesos worth of seaweed production simply due to the El Nino effect. And most of it was the loss of seaweed. And so we briefed the province of Cebu on this technology. We're in the process of applying for a duty exemption, which will enable us to bring in, like they did for the Hainan hurricane, bring in the irrigation equipment that can keep these seaweed farms alive during the heat waves and enable them to continue. This is the beginning. The beginning is to help these seaweed farms and the subsistence seaweed farmers, but eventually to take it offshore, and they've got plenty of deep water, and be able to increase the growing area and restore the productivity that once was in previous decades. This works in the tropics with red seaweeds, and it works in more temperate areas with kelp forest. And the foundation and the principles are the same. It's like marine permaculture, well, soil permaculture works in many different biomes. But you have the details. The local seaweeds, the local flora, the local fauna will vary from place to place. But the principles are what we must found our understanding on, so that in each locale, we can apply the principles of studying the ecosystem, of understanding how it works, and how to build each level in the trophic pyramid to ensure a stable, multi-level trophic system. That's what we're looking for, first at the hectare scale, and then ultimately we'll go to a square kilometer. And the reason for the square kilometer is to ensure that we can get the scalability in deep water to make this work across the ocean, and to make sure that it can actually provide sustainable ecosystem services for years to come. So that's our roadmap at the present time. In phase 1, we did this upwelling valve. We showed that it worked, and we did a Discovery Channel documentary. In phase 2, we won this BlueCanMe challenge in Indonesia, and we actually were able to demonstrate the improved growth rate of seaweeds there, and the upwelling from 420 meters deep using solar power for the first time as a great solution, because it turns out solar is what they have the most of in those tropical regions. And this is a picture of the Catania Red Seaweed, which is one of their economic seaweeds that grew faster and better from this irrigation process. And then in phase 3, we want to be able to take it to the hectare scale and show that we can go from 8 months a year or 6 months a year growing up to 12. And that's really a key challenge because right now they only get seasonal growth and they have to eat their seed corn each year or their seed seaweed each year to make it work. And then in phase 4, we want to show that it can go to larger scale and become economic at scale. This is one of my favorite pictures of Planet Ocean because between us and Australia and the Philippines, we've got 100 million square kilometers of accessible area. Now what's really surprising to many is that the nutrients are just 200 or 300 meters below the surface. And it takes almost no energy, like 1 meter of head of water, to get those nutrients up to the surface. So if we provide a substrate for the seaweed, and we provide an irrigation system for the seaweed, we can actually grow the seaweed offshore and build the habitat for forage fish, which builds the entire ecosystem, just like a kelp forest. And that's the key insight. Now, it's kind of like Johnny Appleseed just entered the Ohio Valley. I mean, that's what it feels like. We could probably spend the rest of our lives planting kelp. And we'd like to ensure that we can create those value chains to enable an entire industry to thrive. And that is an industry that will rely on kelp much more than it has in the past. We've had a century of kelp growing off California and kelp harvesting. And it's a matter of understanding that ecosystem well enough to understand how to restore it, regenerate it, and ultimately scale it offshore. And so that's one reason I love the picture of Planet Ocean. Part of it is understand how do you guide these systems. Deepwater moorings are very expensive. We'd like to develop the technology to ultimately get past the need for deepwater moorings and have a floating island of life that's self-guided, like a satellite system, or we can drive self-guided cars around now. Why not a self-guided boat in the ocean? And it's that principle that we want to move towards. This is a picture of the understanding of the oceans when I was going to graduate school. And that is arrows on a map. And that was pretty much a placeholder. You know, oh yeah, if you're here, it'll kind of go that way. It kind of works. Except until we really started understanding with NASA satellites and other systems what the dynamics of the ocean really look like. And what amazed me was learning that there's more power in the dynamic mesoscale eddies of the ocean than in the steady state currents. And what that means is you can actually sail upstream from one part of the ocean to another, let's say upstream on the Gulf Stream or even the California Current, riding the mesoscale eddies in the ocean. And in the Philippines, we actually measured a vertical shear of more than 1 knot of current, which is amazing. It's like you could build an underwater sailboat with that kind of energy. And so this revelation that in fact, right here, this Gulf Stream is not a steady state current. There are eddies and swirls. The storms of the ocean put the atmosphere to shame. And by understanding these storms of the ocean and riding their energy, riding their currents, we can actually achieve the goals, the navigational goals of marine permacultures to reach a harvest location on a seasonal timescale. So that's research that's currently underway, but it points to a new way to eliminate major cost subsystems and reduce the cost of doing these kind of architectures. My friend Amory Lovins loves to say, if you want to lower the cost of something further and further and further, you've got to eliminate a subsystem entirely. In this case, the fish nets, the fish feed, the deep water moorings. If we get nature to do it, you can actually build a system with higher production and lower cost, and simpler in many ways. And so we see that as a really guiding principle. Our targeted impact is that each square kilometer of marine permaculture should be able to grow 3,000 tons of kelp, fix several thousand tons of carbon dioxide, and produce fish harvests that could be several hundred tons per square kilometer per year. And this is a truly sustainable economic benefit that we see as being sufficient to feed the people on the planet and also to feed the ecosystems themselves. One thing that's not very well known, and I'll go through several examples here, is that we rely upon fish for a lot of EPA and DHA, artificial oil, and all the rest of things. Well, it turns out the EPA and the DHA doesn't come from the fish. It comes from the algae that the fish eat, the macroalgae and the microalgae. And so those communities that eat seaweed and fish, those nations, do very well on the EPA and DHA scale. This is the measure of the intravenous DHA and EPA in people's bloodstreams. And people that are in the green zones, including Nigeria here and Japan, they do very well on EPA and DHA, which is found to be really key to avoiding incidence of Alzheimer's disease. It's key to cognitive health span. And it turns out a third to a half of the population needs to have high levels of EPA and DHA and low levels of omega-6 in order to support that. What's surprising is so many nations, including developed nations like the United States and many portions of Australia and India, with 500 million vegetarians, how do they get their DHA or their EPA? It's a real problem. You have to go to the source. Those sources include macroalgae seaweed, microalgae plankton, and one freshwater fern that I'll show you called Azolla, which is a freshwater fern. It's a bit like duckweed, and it grows in freshwater lakes and streams. And so these rare sources of EPA and DHA are really important for our diets and getting off of a Western diet and onto some of these alternative diets. I was out surfing just a few days ago, just a few miles east of here. And one of my favorite things to do is to eat the kelp when you're out surfing, because it's clean water, it's beautiful, and there's 14,000 species of seaweed, and none of them are toxic. And so I really have enjoyed, I found my favorite kelp just the other day out surfing, and my fellow surfers thought I was crazy, but I got one of them to try it. So it was really a fun adventure. So look for those on EPA and DHA. I met a wonderful woman named Jane Teese, who taught at Harvard, at UMass, and in South Carolina. And she told me at the International Seaweed Symposium about these amazing results associated with seaweed and diet. I'm not sure if I have the chart here, but I was amazed to see that in Australia and America, we have 7 times the incidence of breast cancer that we do in countries like Thailand. And much of the difference is attributed to superfoods like seaweed. And so to do that test, some scientists developed a mouse model for breast cancer. And this was using a mouse model where I think they had added some DMBA, which is a tumor inducer. And with the controls, after 12 weeks or so, just about 100% of the mice had these tumors from this chemical. And the amazing thing was that when they added a small amount, I think it was like the equivalent of a human eating 1 ounce of this macabu seaweed in their water, they had an order of magnitude decrease in tumor incidence for breast cancer, which to me was an amazing result. Now, our mileage may vary, but these kind of seaweed products that are loaded with antioxidants, phytonutrients, and omega-3 fatty acids follow Pollan's principles of eating whole foods, mostly plants, not too much. Although I find I can eat all the vegetables I want and all the seaweed I want, not have any problems. And these superfoods that are minimally processed and have enormous amounts of these nutrients, many of which we haven't even characterized today. This is the kind of thing that we find, because when they do the Alzheimer's studies and they test Alzheimer's patients by the thousands against fish oil pills and EPA and DHA, it actually doesn't slow the progression of the Alzheimer's disease. But they find the patients that are eating whole fish, these whole foods, are seeing a benefit. And so to me, that's really significant. In fact, if we go back to Western Nigeria, there was one study that I read where Western Nigeria, they did a study of 5,000 patients that had the Alzheimer's gene and were in their late 60s, 70s, etc. And the astounding thing is that for some reason, these Nigerians had decoupled the genotype of Alzheimer's from its expression. They saw no correlation between the Alzheimer's gene and the progression of Alzheimer's. And they attributed it to the diet, which in Western Nigeria is comprised of small fish, seaweed, yams, and vegetables, and almost no grains. So this, to me, was the clearest indication that a non-Western diet for the Alzheimer's genotype could be transformational in the progression of Alzheimer's. And when you talk about the cognitive health span of our population, we're talking about enormous consequences. This data will come out more and more in the next few years. But to me, developing permaculture sources of seaweed and forage fish, sardines and anchovies and even salmon, this is really central to cognitive health span. And think of the reduction in human suffering. If we can address this with simple, preventative, whole food solutions, this to me is an enormous opportunity that for us to dive into and work on in more detail. So we found a dozen value streams for seaweed products and these marine permacultures. Food, feed, and fertilizer are just a few. It turns out almost the entire winery industry in California uses seaweed foliar biostimulants to increase the number of grapes and their yield each year. And yet, we don't seem to apply this very much to our vegetables or to our row crops. There's less than 1% adoption of seaweed foliar biostimulants. It's considered too expensive or too this or too that. But imagine, I mean, the experiments they've done in India, 11% higher rice yields, 20% higher vegetable yields. One study in India even reported 56% higher soybean yields through the use of seaweed foliar biostimulants. That's how powerful this potential market is. And I know there are many businesses today that are making their living from the development of these seaweed biostimulants. So there's an example where the permaculture of the sea can go right back onto land terrestrial permaculture and ensure that we've got sustainable yields that will work well. The fish we've talked about, the U.S. Department of Energy has invested $40 million in the Mariner program to develop biofuels from kelps. And we've even spoken with a company called Alginate in New York, which is using alginate to produce knit fibers for clothing. And so that to me was amazing as well. So I found all of these to be really interesting. We're looking forward to helping this industry grow and develop, and primarily by increasing the supply and the demand for kelp forest products and seaweed products around the world. The Western diet is a big problem, as we've discussed. I'll go through just a few snapshots of different industries that we think are very important. It turns out seaweed is what they make the petri dish agar out of. So if you want to grow a microbe, use seaweed. It turns out they call this, I guess it's a prebiotic as opposed to a probiotic. So this prebiotic is great, and it works in your gut. It turns out if you go to Asia, the diversity of their microbiome is far greater than the diversity of the microbiome in the Western world. And so this question of probiotics to help microbiome diversity, we think is a really big opportunity, and another great reason for eating a variety of seaweeds. This is another reference that talks about Alzheimer's resilience. In particular, there's some evidence that the alpha-beta plaques load can be decreased by a factor of 5 with suitable supplementation with sargassum, which I have eaten, and some other seaweeds as well. So I think this is a really major kind of preventative approach to diet. This is a picture of some of the livelihoods in the tropics where they harvest the red seaweeds and do it sustainably. A very large one here is the cows walking on the beach. And I want to share a story with you because about 10 years ago, one of my seaweed colleagues went up to his home country in Nova Scotia, and there was a farmer. And the farmer had a farm that was split by a road. It was by the sea. And half the farm had fences on 4 sides. And the other half of the farm had 3 fences and an ocean. And the farmer couldn't figure out why the cows on the seaside were healthier, heavier, and some say happier than the ones that were on the other side of the fence. And it turned out he watched them eating lots and lots of seaweed. Not only that, the hunters down in New Zealand observed that the deer in New Zealand would go down to the beach at night and eat the seaweed that had been cast up on the beach all by themselves, and the hunters would go down and shoot them at night. So that's how we found out that the deer were eating the seaweed. These natural examples of ruminant livestock eating the seaweed naturally was very interesting. And so some Australian researchers at the CSIRO and elsewhere actually did a study, and they tried dozens and dozens of kinds of seaweed, and they found that there are ingredients in the seaweed that they alter the microbiome and halt the last stage of methanogenesis in the rumen of the cow, which means that with some seaweeds, as little as 1% seaweed supplement can actually cut 90% of the methane emissions of ruminant livestock, which is an amazing result for such a huge part of our industry. This is the foundation of what we call drawdown dairy. And drawdown dairy is 1 part seaweed and 2 parts soil management. But we figured out how to take a cow that's emitting 10 tons of carbon per year and bring her down to -5 tons of carbon per year using seaweed and soil management. So once if by land, twice if by sea. This is a really key principle, and we're thrilled to have this work, and it works not only with Asparagopsis, but with many other seaweeds as well. So we're researching which local seaweeds can we use, how can we make this effective on a large scale, and how can we scale it to the 1 billion cows on the planet, which is a huge number. And it's something that can have an enormous effect on us. Coral bleaching, we started 10 years ago with a small grant from some angels in Silicon Valley, and we went down to American Samoa, cooled off the reef water by 0.5 degree Celsius, and we were shocked that not in 3 months, but in a day or two, we went from a bleach situation where it bleaches every year to reversal of bleaching. And this was by cooling the water 0.5 degree Celsius. That amazed us, and this is a model for doing something with marine permaculture. In particular, being able to, when you bring the water up, it's cooler, and we can irrigate the seaweed, but the mixed layer of the water remains cooler for miles and miles and miles afterwards. And so if your first step is upwell the water, and then you grow the seaweed forest, and then you let the water drift down to the coral reef, we could actually keep that reef from bleaching. Or if it was bleaching, we could reverse it. And that's the principle that we have behind what we call marine permaculture for the coral reefs. Because seaweed does naturally grow in these reefs, we can use those local seaweeds to develop an economic sustainability and build in that climate resilience we're talking about, so that when there is a coral bleaching warning by NOAA and their coral bleaching forecast 6 months ahead of time, we can set marine permacultures up in position. And with high value reefs, whether they're off the Great Barrier Reef or off of Honolulu, they can be set up to actually keep the water a few tenths of a degree cooler, which is all it takes to keep that coral reef alive. Now it's a band-aid, it's a few high value reefs, but it's better than losing the entire ecosystem. And that's what we'd love to extend in the years ahead as we work with the Honolulu Seawater Air Conditioning Company, which does 100 megawatts of deep sea water cooling, but its outflow still has 150 megawatts thermal. And those 150 megawatts can cool off kilometers of coral reef and ultimately feed a marine permaculture offshore. We're going to need approval from the EPA to do that in the United States waters. We have approval already in the Philippines, in Indonesia, and other countries. So as soon as we get these approvals in each country, we'll be able to bring this in more and more, and have these fixed installations as well as the ocean vessels. We're working already with salmon aquaculture in Tasmania. And what we're investigating is, with our current project in partnership with 2040 and the Intrepid Foundation, is to show that if we select the warm adapted genotypes of Macrocystis and we try to outplant them right on the salmon aquaculture system, can we actually regrow the seaweed? So this is what the salmon aquaculture system looks like. And there are grid lines underneath there where we can actually plant some kelps, and they're in a higher nutrient environment. And we're testing the idea that the higher nutrients can give more thermal tolerance. So this is a precursor to a full marine permaculture system, but it's one that we're getting help from the salmon aquaculture industry to begin. So these are one of our active projects that we think can ultimately provide the first steps towards restoring the kelp forest in Tasmania, a project that's currently underway. And for those of us that are more in the freshwater world, whether it's a reservoir, a lake, a stream, or even an irrigation ditch, you might have noticed duckweed and azolla growing in the background, which can be a hazard if it's not harvested, because it can go anoxic after time. But this little lowly azolla can double its mass in 3 days, and is actually a symbiosis like a coral, between an aquatic fern and a marine cyanobacterium called Anabaena. Now, Anabaena fixes nitrogen. So if you had phosphate in your water and not enough nitrate, it would actually soak up the phosphate and produce enough nitrate to produce a great forage for livestock. So it turns out, if you feed your chickens Azolla, and they love it, by the way, you're going to get omega-3 eggs with EPA and DHA in them, which I think is just a wonderful way of flipping it around. If you feed your livestock Azolla, we can clean up our nutrient problems in our rivers, lakes, and streams, and provide healthier forage, fresh forage, for our livestock. So this is an amazing approach, and believe it or not, 50 million years ago, this lowly fern was responsible for laying down most of the oil in the Arctic, including almost all the reserves of the Alaskan Peninsula. So here's an amazing lesson from nature. 49 million years ago, without any human intervention, huge amounts of energy and oil were captured by this lowly Azolla, which was thought to have grown out 1 million square kilometers across the Arctic Ocean every summer. And in the fall, it would die and sink into the anoxic ocean and lay down a layer of oil. So if this works in nature, maybe we can harness Azolla locally to fix carbon, provide a natural forage, and draw down the nutrient levels from our streams and fresh waterways, brackish water. So that's an example of a circular economy. We've done some in partnership with GIZ, the aid agency in Germany, to look at sanitation, agriculture, and marine permaculture all together. It turns out there's some great circular economies to be had. We might be able to get that into more detail tomorrow morning in the workshop. One of them that actually comes from California is called quadruple cropping. It's a very interesting thing. It turns out if you look at the grow lights that are on a grow system, like a LED system, they're mostly red and a little blue. It turns out the plants rely on the red light to grow and the blue light for which way to grow, which direction. And so some bright scientists and engineers came up with the idea that we could actually increase the amount of red light on a plant at the same time that we're collecting energy. These are called luminescent solar concentrators, and it turns out they rely upon a natural dye, a fluorescent dye that's in the seaweed and is the most fluorescent molecule known to man. And this is how seaweeds collect enough light 20 meters down to photosynthesize and to grow. And so these beautiful looking greenhouses were started, I think, in Santa Cruz. They're really something, and they use one of the phytopigments called phycobilioprotein that's actually in the red seaweeds. That's one reason they're red. And it turns out you can actually collect 500 watts a square meter of sunlight for electricity production. At the same time, you're increasing the red light flux to the plants, which is an amazing combination. It's like 2 for 1. Electricity, have your cake and eat it too. So we're in the early stages of researching this. And the way a luminescent solar concentrator works is it takes the blue light and the green light, all the light that's coming in, and it excites one of these fluorescent molecules that are inside the layer of the glass. And then that excited molecule will fluoresce and give off the light in a random direction. Some of it goes down to the plants, which is an increase in red light flux, and some of it gets totally internally reflected out to the edge of your square meter glass, where you put a silicon solar cell. And what's amazing, let's say your glass is 1 centimeter thick. Instead of having 1 square meter of silicon solar cell, you instead have 1 centimeter of cell times 4 linear meters around. Well, it turns out that area is 0.04 square meters, so you've used 25 times less solar collector, and you're collecting about half the sunlight, so about 500 watts a square meter. So it's a really nice way of doing what they call a luminescent solar concentrator, and we're in the process of reducing this to practice and bringing it eventually to market to where you could look at luminescent solar concentrating greenhouses to grow food and collect electricity on the same square meters of land. So this is some of the team of more than 24 people who have helped us. We have volunteers from Australia to Philippines to Europe to the United States, California, and across the US. And we're building our capacity in each of these areas of engineering, technology development, capacity building, and outreach to really spread the word about marine permaculture, develop projects, get on the ground, boots on the ground, and actually get these systems up and running and tested first at the hectare scale and the acre scale, and ultimately going to hundreds of hectares and much larger scale. We're very happy to have the support of Drawdown. Paul Hawken in his book has talked about marine permaculture, about cows on a beach, and we're looking forward to working with them on subsequent Drawdown events, including this new movie called 2040, which just came out in Australia. It's hit number 9 on the box office there over the last 2 weeks. And that's against all of the feature film releases. So we're really happy to have a documentary that's doing so well. And I think there are plans to bring it here to Santa Barbara in the coming months. I think Margie and Wes are working on that. And we're looking forward to being part of that event, and I encourage it. Part of what is going on with that is actually the Intrepid Foundation has a program that's been offering a dollar-for-dollar match to any grants for the Tasmanian Kelp Forest project. And so with Australia's help and folks from around the world, we're hoping to accelerate the growth of those kelp forests and show that it can actually work in Tasmania, because today's Tasmania is tomorrow's California. And what we must do is build the political will to restore and regenerate our kelp forests for generations to come. And with that, I'll thank you and open up for questions. Some microphones there, but go ahead with the question in the center.
Yeah, thank you for a very, very nice presentation. Question on the media, on the actual, like, what is the media that will attach to? Is it designed to engender more marine life and things like that?
Yes. Great question. So the question is, what is the substrate that this system grows on? We took a lesson from the Natural Energy Lab in Hawaii, and they have a history of 50 years of deep water pipes that go all the way down to 2,000 feet deep. And they actually, they built it out of a polymer, high density polyethylene, and it has, they dove on it in just the last few years to see how it was doing. And amazingly, it had a beautifully resilient, with no cracks, no problems whatsoever after 50 years. So we use that as a baseline. A lot of the aquaculture fish pens have also used high density polyethylene. And one of the benefits of that material is that we're able to recover it 100% and reuse it 100% in a recycling context where you melt it down and you actually re-extrude it to make another permaculture or other high-density polyethylene material. We're also looking at using recycled high-density polyethylene as the original starting material, both as a way of reducing costs more than a factor of 2, and also being able to ensure a full circular economy for those materials. Eventually, today we're experimenting with the use of bamboo as well for some of the structure, because it's highly regenerative, easy to grow, and very fast. And in the future, we may be able to move increasing portions of the system to bamboo, but our initial material is polyethylene. We're finding that the holdfasts are able to attach to the polyethylene, and there's some biofouling that occurs on the surface and deeper down, so you get multiple species going. But it's a good material for now, and it's one that's 100% recyclable.
But that's the material plan or the actual design of what it's on. And you consider the interstitial space, because you said the fisheries are unknown. So if you create habitats for the kelp to sit on, is that something that's in the mix?
Yeah, we need to design better and better structures, and right now we're using this great tool from the 1970s called Zone Tool, which is a geodetic space frame structure to design the new architectures that are going to be resilient as we go forward. So I think understanding that three-dimensional farming, that three-dimensional space, is going to be critical. I start with the principle that the kelp forest ecosystem works pretty well. It's canopy forming. It grows up quickly from 25 meters, forms a habitat in a canopy, and the fish like it. So it's a good place to start, but we may find opportunities to go with the space frames as well, and that's something that we should keep in mind as we go forward.
Of course.
Question over here?
Yes, thank you for the information. My question is, the kelp forest, and we have the rainforest. What is the amount of kelp forest we have right now in the ocean?
According to the chart that we looked at, it's about 3.5% of the area is algae beds and reefs. So it's a small area, but it has a high impact. And the question is, can we go beyond that? And I have to see if I was remembering my numbers correctly. But it's a small area today, but I'm reminded of the end of the Cretaceous Tertiary boundary, where by meteor or other means, we lost all the dinosaurs. And the mammals were living in little tiny corners of the planet. And yet that was their moment to actually thrive over enormous areas. And we take an ecosystem that's working well, like a kelp forest ecosystem, and if we can create the conditions that enable it to thrive 200 kilometers offshore California, suddenly we've got a technology that learns from a natural ecosystem and can scale it. And so we look to that similar kind of natural metaphor, that if we can create the right conditions, we can create marine permacultures that can thrive on the open ocean.
Thank you.
Okay, over that side there.
Yes, in the back.
You got a microphone.
Okay, 2 questions back there.
Hi, I'm wondering if you think there's a certain type of kelp or species of kelp that we should focus most of the restoration efforts on?
Good question. Well, here in California, I love the macrocystis that grows right offshore here. But interestingly enough, when I was surfing, I didn't see the macrocystis nearby. It was a laminaria or another brown kelp that was growing because it was a heavier surf zone. So depending on where you go, you get different ones. But there are hundreds of species here that we can look at. It turns out macrocystis is one of the fastest growing. It can grow up to 1/2 meter a day and get to lengths of 65 meters or longer. So it grows very, very quickly. It also has a greater need for nutrients. So that's why macrocystis is one of the first to die back when you do have nutrient deficiencies or warm water. And so it's a trade-off really between growth rate and nutrient levels and all the rest. And so I think we have to be resilient in our marine permacultures, and that may mean ultimately multiple species of kelp growing. But starting with some of the faster growing ones is a great plan for now. And the beauty is having thousands of species to work with. I think we've figured out how to commercially use just a few dozen.
Yeah.
So we're at the tip of the iceberg.
Just a quick piece of information. Santa Barbara used to be like the center for kelp research. There was a professor called Moser, I guess the way to pronounce his name, at UCSB. Look at his work. He had a 1,000-acre reserve off the coast where he was experimenting with growing different kinds of kelp. And he was thinking about the changing world while he was doing that. So he was gathering and experimenting with different kelp because he knew the world was changing. And he felt like we needed to have kelp in this area that started to respond to the changes of our environment. So not too many people know about him, and that UCSB was a big center at one time.
That's great.
How were you spelling his name?
Yeah, Nuschel, I'm familiar with Nuschel's research and some of the research at Caltech in the 70s and 80s as well, all the way down to San Diego.
Thank you for bringing awareness of this kelp issue to us here. As someone that free dives the reefs off of Santa Barbara all the time, I can say that this year we've seen maybe the lowest growth of kelp that I can remember in my few years of life. But yeah, it's definitely pretty troubling. I am trying to have a little bit of a leap of imagination in my question, where you were talking about the degradation of our kelp forest due to temperature in that thin band along the coast and along the islands where we're going to lose it, and then using technology in order to grow like open ocean marine kelp. And I guess my question is, has an ecosystem like the one you're talking about, it seems like one that's never existed on the planet before in terms of like kelp floating around in the open ocean, and then also, do you see any of this technology having the potential to actually regenerate the indigenous kelp forests that are growing close to the coast?
That's a great question, and as a fellow freediver, it's on my bucket list to freedive on marine permaculture. So I think that's going to be a great opportunity. We've started offshore because to start a kelp farm near shore in California today requires the approval of 17 state and federal agencies. And groups like Pharmacy are still, after 10 years, working to get their final approvals. We're coming up with an alternate way, and the alternate way is to build a marine permaculture vessel, register it with the U.S. Coast Guard, and sail it out to sea. And we're talking about 2 months to production and growing of seaweed. Now, we'd love to grow onshore. We'd love to have the support of California Fish and Wildlife. But quite frankly, there's still deer in the headlights. I mean, they've lost 95% of the Miracistus kelp forest north of San Francisco. And they were approached by some entrepreneurs in Silicon Valley. And this entrepreneur came up during one of our workshops to the state agencies, and they said, let me get this right. You've lost 95% of your forest, and you're still not willing to test anything to regenerate it. And I said, well, you know, we're worried about losing the last 5%, so we don't want to do anything that might stick, you know. That's the problem we're dealing with. And that's one reason we're working in Tasmania today, because they built the political will to restore the kelp forest right on shore. Okay? And so today's Tasmania is tomorrow's California. And what we have to do is work to build the political will to restore the kelp forest from the tip of California all the way to the Mexican border. And that's our challenge and our opportunity. We'd love to do it onshore. We cannot wait the decades of contentious debate to get through all those agencies. We've got to build the kelp forest today. Thank you.
Yeah, so in the state of California, I'm following the CARB's goals and the 2030 implementation plan for natural and working lands, and the tentative goal of increasing the rate of seagrass restoration ×2, and that we're like waiting for a more ambitious goal that expands beyond just their funded agencies, right?
Yes.
And so that to me is the node that I think we would poke at in order to build that will and to move the fish and wildlife. Do you have any interaction with those people?
Yes, we do. CARB has been very instrumental in establishing the methane reduction guidelines for dairy and pastures. And to the point, I believe there's a plan for a 40% reduction in all dairy methane by 2024. And half of that might be from the poop and the digesters, but half of it has to come from the ruminant livestock methane reduction from cow burps. And that, we believe, the natural, organic way of doing this is going to be with seaweed, because it's a whole food, it's well tolerated by the cattle, the UC Davis research supports that, and the cows like it, and it works. There are a number of chemical approaches to doing it, which quite frankly are not organic. They try reductionist approaches to purify the chemicals from seaweed, produce toxic effects in the cows. So there's something about the whole seaweed that's not in the purification. So once again, Pollen is right. We've got to eat whole foods. And our livestock have to eat whole foods too. So CARB is instrumental on that part of it. And I think there's a big opportunity to restore and regenerate seagrasses and seaweeds and kelp forests. And what's under-recognized today is that kelp that we grow, actually a good fraction of it ends up in the deep part of the Santa Barbara Channel, where it's anoxic today. And so that means that carbon is going to stay there unoxidized for centuries to come. And so it turns out, when you get the seaweed down hundreds of meters, as you can with a processing system, the seaweed will sink hundreds of meters a day. If it goes to the bottom of the Santa Barbara Channel, it's going to be anoxically held there for hundreds of years. And so that's a huge opportunity to characterize that and understand how it works and build a sustainable seaweed industry that can actually become a net carbon exporter at the same time.
Could I follow on?
Please.
So I'm from Ventura County, and we're like right in the hot part of our general plan update for 2040. And right now I'm like writing a policy for our county. Counties shall encourage, or what exactly can a county do?
Right. I think encouraging the development of a mariculture industry that's sustainable, that recognizes the ecosystem services that go along with marine permaculture systems, whether it's seagrass or seaweed, nearshore or offshore. That's a huge opportunity for our towns and communities here to lead the way on establishing best practices. And I think the more we can move this forward, we have the opportunity to be the center, if you will, of the United States effort in mariculture and be able to do, let's say, the ecosystem sustainability and the carbon export, because we have this incredible resource to the Santa Barbara Channel. It's one of the 3 basins in the world that has anoxic deep. I showed you that Arctic Ocean, and that Azolla event is associated with the drawdown of hundreds of parts per million of carbon dioxide during that same period of time they were laying down and fixing all the Azolla. So the Azolla is an answer to food, it's an answer to ecosystems, and it's an answer to carbon balance. And it turns out Santa Barbara Basin is one of the 3 anoxic basins of the world, along with the Black Sea and the Cariaco Basin off Venezuela. This is one of the 3 great anoxic basins of the world, and it's a place where you can safely sequester carbon without it oxidizing in the deep. So it's an amazing opportunity for our local communities to get involved in understanding the science and the technology to actually sustainably export carbon for decades and millennia to come.
Could I add something? Margie and I go to the sea level rising meetings. There's not too many people show up at them. So you find out a lot because you can ask questions. So our focus was on kelp, which is like, they're not even on the radar, but we asked them because, you know, kelp can be like mangrove swamps. It can absorb the energies of king tides because they're always talking about all these things that they have to put in. So this interesting question that I asked, in Carpentria, they said that they actually control 3 miles out in the ocean from the city, which I have no idea. And I don't know what that 3 miles is, but they said they have jurisdiction over 3 miles. So I don't know what other cities have, but I think it's a good idea to find that out. It caught me by surprise when they came back with it.
Yes,
Yeah.
3 nautical miles for state and federal waters.
And that's what CARP said, that it had some influence over it. And then we brought up that they should put into their sea level rise plan kelp. So we did it in Santa Barbara too. So we've been working at it. So you just have to go to those meetings and then stand up and ask questions. Because they don't have all the answers and they don't know where to look, and the consultants they have don't have that broad a bandwidth. And we know some of the consultants that used to work for the county, so when we go to the meetings, we corner them. So chit chat with them. Anyway, so enough.
Thank you,
Over
Wes.
here.
Other questions?
Right here.
Okay, so this is a little divergence, but you mentioned at the beginning that you started with soil and you were working on soil and you focused on this. And then last night you and I kind of touched on food forests. And I was blown away by all the incredible things. I couldn't absorb it all so much. Who is doing this kind of research on terrestrial food forests that we could do this kind of stuff with?
Well, that's a really good question. I think the Biggest Little Farm is a great beginning example of this, and they not only are doing a 200-acre farm nearby, but they know even more experts that they've drawn on to make that happen. And I know several of our friends and actually our hosts here in Santa Barbara have a very small food forest right in their backyard, Zone 1. So I think there are many examples here in Santa Barbara, and I think that's a great place to start because ultimately we can turn our lawns into victory gardens, and those victory gardens can be truly multi-trophic, and they can be growing a food forest on land. And you know, I've actually, when I was up at Esalen, I've dragged some kelp up off the beach and put it into their compost pile, and they were like, "Oh, you can put kelp in your compost pile." That was really a revelation to them. So we can be getting some seaweed off the beach and using it on our gardens because of all those micronutrients. And the hydrocolloids are really good at holding moisture too. And so it turns out there's so many benefits to adding seaweed at that level in addition to the foliar biostimulants we've talked about.
So what about the scientific research applying to the food forest? Because there's a lot of kind of lay people developing stuff, Jeff Lawson and all those people, but
Right.
Are we getting the scientific community?
I was part of the Carbon Farming Innovation Network, which has a lot of work done at Cal State. I think it's in the Central Valley, and I can actually point you to several tenured professors in the UC system that are working on multi-trophic approaches, including cover crops, including carbon soil, carbon farming. And there's some new developments that I know of where this work has been brought forward very quickly and is being scaled. So I can send you some of those references afterwards. And I think it is once it by land and twice it by sea.
Right, been waiting for a long time.
Okay, we've got one over there first.
First,
Yeah.
Cool. Thank you so much. It's been absolutely fascinating, and thank you for bringing the local knowledge to Santa Barbara about these potentially really amazing solutions. And my question is about sargassum. So when you're looking at offshore seaweeds, I think of sargassum, and it's interesting how the patterns have shifted quite a bit in the Caribbean. Now it's this kind of pesky seaweed that's showing up on the shore there. Curious about industrial applications, if you thought about nutrient, if that could even be sunk in some carbon sink sort of way. And then a separate question really is just about what the potential for carbon markets is. I mean, with something like Project Red, where they were looking at carbon credits for terrestrially with forests. Do you see that happening in the future in this marine permaculture kind of scenario?
Yes, I think those are very important questions. Sargassum is one of the most valuable seaweeds, it turns out. It's valued in some markets at over $5,000 a ton, which is really substantial. Harvesting it on a seasonal basis is challenging. They tend to get what they call golden tides, which is golden sargassum coming in all at once. But it's episodic, right? It happens from time to time. So we have to think architecturally, how do we design a vessel that can capitalize on these harvests, capture enough of the sargassum to keep it off the Caribbean beaches, which, by the way, it's probably forming in such vast quantities because of all the nutrients pouring out of the Amazon River and going all the way up to Texas and Mexico. But there's an opportunity in there. And the opportunity, there's sargassum in Asia, there's sargassum in the Caribbean as well. And it is a good example of a floating seaweed. So there are plenty of things that can be done, particularly on the fertilizer and the biostimulant side with sargassum. And ultimately, yes, we've seen evidence of sargassum in the Sargasso Sea 2,000 meters deep on the seafloor. And so it is amazing how much carbon that can be sequestered. And we think the combination of a rapid harvester, an at-sea biorefinery that's going to process the seaweed and can actually release the seaweed to depth, that's a great combination. And we think that's the beginning of a carbon methodology. Now, because of the London Protocol, we need to be, mariculture is exempted by right. Our primary purpose needs to be feeding the world and regenerating ecosystems. But while we're doing that, we can measure the carbon export of these processes and potentially enable the carbon markets to grow with these kind of approaches. And there's truly enormous room in the sea. There's 50 times as much carbon today in the ocean as the entire atmosphere of the Earth. Said another way, if you take all the carbon out of the atmosphere and uniformly distribute it throughout the ocean, it'll change the concentration of carbon in the ocean by less than 2%. So the problem with carbon in the ocean is not one of total quantity, but its distribution. And it turns out the biological pump, including kelp forests and plankton forests, are what pumps that carbon out of the surface ocean and into the middle and deep ocean from whence it came. So our challenge and our opportunity is to get nature back on track, balancing carbon in the ocean with the carbon pump and get that to work. And this would be a great way to accelerate that. Thank you.
Your question, I'll just quickly butt in, but we had a guy called Tom Duncan come. Take a look at liquid token.
Mike, use my question.
Okay, yeah, where's the mic? I'm sorry to hog it, but I think it's an important question he asked because it, take a look at liquid tokens. We had the guy who formed that company here in Santa Barbara about in February, and he did a talk. His workshop was on that. And it uses blockchain to measure. So it's not like a Bitcoin, like we have Bitcoin to create value. This is the blockchains are used to actually evaluate how much carbon and everything else. And I was talking to him because I was asking him about Brian's work and where liquid tokens can come in. And he said, have a conversation with me because I think there is. And this is the way of monetizing ecosystem restoration and directing our markets so that they are funding big change that is a change that helps the natural system, okay? And that's what liquid tokens is about.
So along those lines, we've been working with Nori. We actually did a podcast with them last summer, and they're working on this blockchain approach where a Nori token will represent a ton of carbon dioxide. And we're looking and exploring the idea of developing a kelp coin with them, where a kelp coin would be a token that represents a ton of living kelp on a marine permaculture kelp biomass. And so it would be a hard currency or a hard token in the sense that each year the total, we would assess the total mass of kelp that's growing, and it would normalize the number of tokens to the growing mass. And so that would effectively create a backed currency, if you will. And when you retire a kelp coin token, you would be sinking a ton of carbon dioxide into the middle and deep ocean. So this is our early thinking about the way tokenization could help to scale in a distributed grassroots way, the ability to really regenerate life in the ocean and balance carbon at the same time. Question in the back.
I'd like to rewind back to a couple of slides which depicted the Kelp River going from California to Mexico.
Yes.
And one of those slides had a diagram of, it was a map of, it showed the harbor, and there was a red polygon with a red arrow pointing at it.
Okay.
And I know you've got 17 agencies to deal with. And you've got purple sea urchins. So I'm wondering, what do you have in mind for that red polygon? Are you like trying to establish just an island and get rid of all the purple sea urchins and expand from there? I mean, what would be the plan if these 17 agencies showed up at your doorstep and just said, just go ahead?
That's a great question. There has been some work in Northern California on trying to develop a commercial market for purple sea urchins. And this is a bit analogous to what happened in Southern California in the 1980s, I believe. And the challenge is this: the urchins themselves are starving. So there's an urchin baron, but there's a zillion urchins, but they're starving, and so they're not very commercially marketable. So the current plan calls for harvesting urchins and trying to rehabilitate them. But to rehabilitate them, you actually need kelp. You got to feed them. So enter a marine permaculture, where if we can grow enough kelp in Northern California, a little offshore, and sustainably harvest to rehabilitate the sea urchins, we can give them a one-way plane ticket to Japan and sell the uni for $100 a pound. So there's a nice, perhaps sustainable approach. We start with something that's offshore and not very threatening. And then as that becomes more acceptable, we could probably move these permacultures closer to shore, where they're floating above the urchin baron, and they're not susceptible necessarily to the urchin devastation. So that's one path that we see to helping get the industry and commercial interests back on track to actually rebalance the sea urchin baron and get the kelp growing again. So we're thinking of that as one possible mechanism. In Northern California at least, our mileage may vary in the Santa Barbara area, but I think this vision of kelp ecosystem services throughout the Santa Barbara Channel is a really powerful one that I think gets us closer to pre-industrial levels of kelp throughout the Santa Barbara Channel. Thank you. Yes.
Thank you. A lot of my questions were answered, but you described the need to garner the political will to go backward and restore. And things came up in my mind as you were talking about how or whether you might have a vision of garnering the corporate machine's will in America. And your talking here is so valuable. How do you expand your lecture model to Verizon and Amazon and the big polluters and DuPont? And
Right.
do you have a plan to get in the face of corporate America to raise their consciousness and have them shell out
We
a
do.
few bucks, and the DoD can decommission an aircraft carrier to become one of your offshore farms? So it's a weird question.
No, it's a great question. I'm happy to say that we're part of the Carbon Farming Innovation Network. And what I'm pleasantly surprised at is the number of Fortune 100 companies that are dedicated to carbon farming. And one of our projects is literally Drawdown dairy. Because, I mean, who here doesn't like dairy? Ice cream, cheese, I mean, you know, and yet I've got this vision that I want to share with you, and that is, take a liter of milk here on the stage. And to create that liter of milk today takes a cubic meter of carbon dioxide, which if it was helium, would be enough to lift that liter of milk all the way to the ceiling. And if that's not bad enough, take a kilogram of cheese and put it down on the table, and it requires 10 cubic meters of gas, greenhouse gas, in order to make that kilogram of cheese, which is enough to lift the cheese and the table up to the ceiling. So the problem is, we've got, in 2030, we're going to still have dairy eaters. And what we need to do is reduce our intensity by a factor of 5, and then use things like Drawdown dairy to take us carbon negative. And that means literally 1 part seaweed, 2 parts soil management. These are the technologies that we're talking with the Fortune 100 today to build a Drawdown dairy in the next 5 years. And why couldn't that be in Santa Barbara? Why couldn't that be in California? Why don't we get the will to show that it works and that we can have sustainable livestock, rotational grazing, and all the practices that are needed to make this work? That's the engagement that we have today, and I think we can scale it to the point where I think we have enormous buying power in our products, and what we need to demand is radical transparency. That radical transparency starts with a QR code on a product label, or in a restaurant. If I'm eating a fish, I want to know where that fish came from. What was that fish eating? Is that an omega-3 fish, or is that a grain brain fish? Because those are the kinds of transparent products we have to demand by voting with our feet. My advisor and colleague, Dick Feynman at Caltech, said vote with your feet on projects. And I think what we have to do is vote with our feet on each and every product purchase, so that in the future, there'll be 2 kinds of products: radically transparent products and products that are going extinct. And if we make that happen, I think we'll get a lot of attention.
Is Wisconsin interested?
I hope they're interested. We're figuring out how to preserve those seaweeds and get them to Wisconsin as well. So, thank you. Next. There are a lot of cows in California. Millions, 5 million dairy cows at last count, and a regulation that by 2024, we've got to cut those methane emissions by 40%. So it starts right here in California.
Yeah.
Yeah.
1960. Over here?
Yeah.
Back here.
I just want to update people on the
Come back. Go ahead.
local. So so I'm the local shellfish farmer, and just wanted to update you on some recent developments. And so recently, one of the ARPA Marine grants got relocated to my farm, and we were able to get it permitted for 60 acres of microcystis, and we just planted it.
Congratulations.
Yeah, so so things are changing with our regulatory system. People are interested, and I was kind of skeptical coming into your conversation, but it does, you know, the sort of the next step would be sort of a hectare, and it's totally feasible. It's
excellent.
It's exciting, and
it's possible to do. There's a lot of interest. And the woman talking about Ventura, you know, there is a shellfish farm that they want to install off of Ventura, so people want to do this stuff, and the regulatory agencies are listening, and it's possible. So,
Congratulations! I'm so glad you passed those regulatory hurdles, and you're here to making it work.
I bring it home and keep it here.
Excellent, excellent. Thank you. Yes.
In 1969, there was this iconic oil spill, and it led to the development of several environmental groups along the coast. From the oil drilling platforms off the coast, and I'm a pacifist. I believe in beating swords into plowshares, you know. And gee, there was this oil pipe, you know, from the platforms. Gee, we could, you know, look at repurposing those oil drilling platforms to oil producing platforms from the kelp and other products and stuff. I wonder if you have some thoughts along those lines.
I think there's enormous potential, and early on we might be able to work some agreements with the NGOs that are driving the Rigs to Reefs program. I think there is a lot of contention about how that should be done, and so that remains to be seen. It's a great stepping stone towards what we see as being ultimately open ocean mariculture. And so if we can repurpose these rigs, we should try to do so. We need to work with all those local groups, and we have to understand that there are many desired uses for them. I think they're great habitat right now. It'd be great to try some small-scale kelp forests and shellfish and finfish along there as well. That has to come in stages, and in the meantime, I think we need to try hectare-scale marine permaculture at the same time. So let's go forward on all those fronts. We don't have the time to waste on that. And you know, I think Rigs to Reefs has been extremely successful in the Gulf of Mexico. And I think there's a lot more resistance to it here. But we need to consider the successes in the Gulf of Mexico in thinking about how do we move forward with a Rigs to Reef program in California. So thank you for that. And along those lines, you know, eutrophication is a big problem right on the coastline. Okay, and that's the 1% of the ocean that we see the most of. But offshore, there's actually an opposite process. It's oligotrophication, where there's not enough nutrients and the water is too warm. And that's probably a larger problem. And so being able to have those nutrients sufficiently offshore that they're not impacting coastal ecosystems is a challenge for us and an opportunity. And you know, it could ultimately help the shellfish industry as well as the finfish and the kelp. But it's something that we need to understand well and deeply, and I think that involves marine ecology and really understanding these ecosystems well enough to be able to replicate them. And I'm going to quote another quote from Dick Feynman. He says, "You don't understand a system until you've built it." And I will add to that, you don't understand an ecosystem until you've rebuilt it. So that's our opportunity, is to rebuild the Kelp Forest ecosystem.
What might we expect tomorrow at the workshop?
Can I make an announcement? Because many people or there's some people beginning to leave. So the workshop is at Antioch University, 602 Anthropocene Street, and it's on the upstairs level. It's room 343, I think. But just go upstairs and we'll locate Anacapa Street. Also, we forgot to mention one of our great co-sponsors, Santa Barbara Aquaponics, and Kevin is with us this evening.
Yay.
I'm very sorry to have left that one off. And then briefly, before people leave, and then we can go back to questions, some of the upcoming events that was mentioned was the Beaver Free film will be shown on June 28th. Is that right, Wes?
Yeah, down at BC Central, outside movie. Yeah.
And then the 2040 film that Brian mentioned, that will be at the Marjorie Luke Theater, but we're still working on the date for that one. Any other announcements, Wes, before people leave? And tomorrow the workshop begins at 9:30. I forgot to mention. And upstairs there is a honeybee cafe, so you can get your coffee, your food, or whatever. And if you haven't signed up already, go on Eventbrite tonight or sign up on the sheet out front. Thanks.
And we'll plan to do a deeper dive into some of these products and some of these applications and some of the implications. So if there are more questions and more details of the health benefits, the nutraceuticals, the food, feed, and fertilizer, and the seaweed foliar biostimulants. We'll be able to dive into those deeper tomorrow morning. So, thank you very much.
Yeah, we still ask questions, we've got time.
Okay,
Thanks. We
all right.
deliberately keep lots of time.
I'll talk to everybody's
Those who
later.
want to stay.
So, we're permitting a 2-acre study reef in Goleta Bay to help kickstart restoring that entire 220-acre historic kelp bed. Modernization is the fishery project, and we've actually pulled the trigger on the permitting. So, we have the deepest empathy for people that are trying to permit anything in the marine ecosystem, and we know how it goes. So, I think it comes down to a matter of priorities in terms of what young people and students compel their governments to support. I mean, we have to realize that the people that work at Fish and Wildlife and things like that, these people are appointed by the governor. So if you want to see change happen and you want to see our agencies embrace solution-based projects like this, the governor has to hear from you and say you need to replace people inside Fish and Wildlife and state lands and the Army Corps and all these different agencies that actually are willing to embrace the progressive nature of what something like this actually is. So I think it's very important to make a note of that.
I agree with you on that, and I think we're transitioning from an era of doing fewer bad things in the ocean to one where we can actually do more good things. And this is about regeneration and really understanding those ecosystems well enough to make that happen. It's a gradual transition, but it's one that we need to embark upon. And so I agree with you there.
Okay, over here. Okay, I've got one here.
Go ahead and we'll come back.
Finally, I really want to pose this question, which might be a little bit critical. So what I hear from now, it would be really great if we could multiply this effect kind of as fast as possible. On the other hand, I see that you filed patents for your technology. So how would you support people who would actually be willing to copy your technology and in the end would kind of infringe your patent? Is there a free license planned, or how do you do that?
Yes, we're planning what's called reasonable and non-discriminatory licensing, and the primary purpose of the licensing is to develop an industry association. Because if marine permaculture has ended up on the beach as a big wreck, that would be not very good for the industry. And so what we need to do is to develop an industry that's going to self-police, if you will. And that means, without a lot of regulation, developing best practices within the industry that work sustainably. And along those lines, whether it's hectare scale or 100-hectare scale, we need to monitor for side effects. If there's a dinoflagellate harmful algal bloom in the area, continuing to upwell water could be detrimental. So we need to be able to monitor for existing harmful algal blooms, make sure we're not exacerbating the problem. These are the kinds of best practices that we need to develop as an industry and ensure that it's going to go well. So the licensing process is not only to enable investment in the area, in the industry, but to be able to ensure the quality that's needed so that that industry can grow in a healthy way. So thank you for that question.
How we doing?
We had a question up front.
Back there, corner.
And one in the back.
Can you say anything about the East Coast?
Yes, East Coast questions. Rebecca and I are both based on the East Coast right now. We're between homes in California. But there's a lot of seasonal growth in the East Coast. Particular Maine seaweeds are being shipped down to New York to high-end restaurants to be, spaghetti seaweed is one thing I'm still on my bucket list to try. And seaweed salad extraordinaire. I mean, really amazing fresh seaweeds are going to top-end restaurants right now in New York. I even heard that some of the seaweed in Moss Landing is being flown to New York as well as San Francisco for top-end restaurants. So it's a very interesting high-end market. In addition, there are a lot of biostimulant products and seasonal kelps that are grown on the East Coast. And we're even working on a seaweed sauerkraut, and we've got some fellows coming in. It's going to be probiotic, antioxidant, phytonutrient, everything else, and we're going to have a shelf life of 3 to 9 months. So keep posted. I'm hoping next year we're going to have a product out. And we'll keep you posted on that development. Amazingly, there are some sauerkrauts that are a little bit like this down in Australia. They're only 1 or 2% seaweed. We're hoping we'll get to more seaweed than cabbage. So I think there's a lot of opportunity up and down the West Coast and the East Coast. And I'm looking forward to really turning this around into a foodie adventure. 14,000 species of seaweed to explore. Question in the front?
Oh, just a comment and another thought about all of this good news makes me a little less worried about that massive ocean of plastic or that little island of plastic somewhere. I don't know where.
Yeah, the plastic is a big worry.
The island of plastics.
Right. I haven't seen that island yet. I think plastics is a big problem. The United Nations forecasts that by 2040 we may have more plastic than fish. Yeah. I think we have many people working on the plastics problem, and we're making some good progress there. We're focused on the more fish because, like it or not, 3 billion people depend on their protein to have enough fish. And so that's the part of the problem we're trying to address and be sustainable on the use of any artificial materials with 100% recycling. So that's our challenge and our opportunity, and we're looking forward to developing those best practices.
I wish you could use that island to feed the offshore, all the offshore.
It's a good question. I keep thinking of the island of life from The Life of Pi as being a floating island of life that we hope to regenerate. So that's our hope and our interest. Any other questions? Yes, in the back.
When you initially opened the presentation, you were talking about the coral reefs growing before every mass extinction. Is there any reason for that correlation?
Okay, it may have not been completely clear. The coral reefs grow under normal conditions, and then right at the mass extinction, their growth stops. And it can be because the sea level rose and they were drowned, or it could be because the temperatures got too high, and that tracks the CO2 spikes. Because when the CO2 goes up, the temperature goes up. When the temperature goes up, the CO2 goes up. So those covariables mean that you're overheating the corals and you're losing the deposition of coral reef. So it disappears from the fossil record. So this ecosystem as being kind of the canary in the coal mine is really key because we've seen a loss of half of the coral reefs on the planet so far. And the geologic record says that the Earth system views that as the early warning sign to a mass extinction. And so I think that evidence is one that we have to heed very closely. I love studying the geologic history of the Earth because it tells us what is the Earth system capable of. And the fact that the Earth system is capable of an anoxic ocean, and we're already 2% of the way there, just from the past few decades, tells me we've got to pay a lot of attention to our oxygen production in the ocean, whether it's done by macroalgae or by microalgae. And that overturning to prevent a stratified ocean is essential to keeping the oxygen moving through, to keep the nutrients moving through, and to keep the ocean alive. So I think our challenge and our opportunity is to keep that circulation is good for your legs and it's good for the ocean. And what we have to do is keep the ocean circulating. And this is a great way to do it at a net positive present economic value and really monitor those ecosystems at the same time. So studying our geologic history, if we don't understand history, we're condemned to repeat it.
Hi, thank you, very fascinating. My question is about the artificial upwelling. I was recently explained by the biogeochemist Dr. Brian that every 1,500 years the entire ocean switches from the top to the bottom due to the circulation patterns. And that means that the warming that the ocean is absorbing now in 1,500 years will influence the atmosphere. I'm wondering if the upwelling at scale could accelerate that warming process, or it would have some detrimental influence.
That's a very good question. I know Tom Barrow, he's based in Boston, and I've enjoyed working with him over the years. The scale is 1,000 to 4,000 years for overturning circulation, but it's ignoring one important physical oceanographic fact, and that is new bottom water is made every winter off of Antarctica in the Southern Ocean. So it's a renewable resource from that perspective. And the amount of bottom water that's made depends upon effectively sending off into space all the excess heat in the Antarctic winter. So by improving the circulation, you can actually increase the transmission of heat into space. It's not a zero-sum game. And so looking at the total equation is essential. And it turns out clouds are the big mystery in the climate equation. When the Earth gets warmer, do you have more clouds or less clouds? If you have more clouds, you'll probably reflect more sunlight. But our colleagues at Caltech have been looking at this question very closely, and there's some preliminary evidence that the warmer it gets, the fewer clouds there are. And if that's true, instead of having a reflectance or an albedo of 80%, we have a reflectance or an albedo of 30%, which means we're absorbing even more sunlight, which is an exacerbating runaway feedback loop. So, understanding the clouds and how they work, right off the coast here of California, it turns out the plankton forests are largely responsible for creating the little nuclei that create the stratus clouds that come in off Santa Barbara. So it's an amazing feedback loop. We like to think that the climate of the Earth affects life. But what's less well recognized is how life affects climate. And it turns out dimethyl sulfide that's made by these phytoplankton produce little sulfate particles that end up nucleating the fog that we get in the marine stratus layer. And that's largely biologically assisted. So this question of understanding the climate well enough and understanding the marine ecosystem well enough and the soils well enough to understand how these systems interact is essential to getting it right. And that's the deep understanding that I think we need to strive for. I was astonished to learn that the forests in the Amazon determine the rainfall nearby. That is this evapotranspiration system that even works in the middle of the United States. You end up getting rains in the southern parts of the mid-plains that over the summer work their way up to the northern plains because they evaporate each day and then they rain down in another place and they evaporate and rain down. So your ability to hold moisture in the soil determines the rainfall down the road. So this is a way that life is affecting the climate. And so I think these interactions between life and climate and back to life again can be a higher level of regeneration of the planet. And it requires, I would say, a new breed of student, a new breed of scientist. It's more holistic. It's really about understanding the ecosystems and the earth well enough to work well with both. And that's something we strive for with our interdisciplinary work at the Climate Foundation. It's to have the marine biologists and the geologists and the climate scientists working together. And so I think this leads to a more holistic knowledge rather than a specialized knowledge. And I think that's what we need for land-based permaculture and for marine permaculture. So thank you for that question.
I'm blown away. Hearing your talk, it's the most hopeful news I've heard about the ocean in a decade. And I saw Paul Hawkins speak at Pioneers years ago, and he said that the Earth's immune system is waking up, and that we are the Earth's immune system. So thank you for being such a strong immune cell
Thank you.
for the planet.
Well, it really gives us great hope, and I think it comes back to what the farmer in The Biggest Little Farm said, and that ultimately we are the consciousness of the planet, and it is our consciousness of what we're doing to the planet and the life on the planet that will turn this around. So literally, it is building that will to regenerate life in our seas and soils that will make the difference. And that's why I have great hope for the future. So thanks to all of you for being stakeholders in this process. Yeah, we'll see you tomorrow. Thank you.
Good use.